Hello, everyone, and welcome to today's SANS webcast, Cloud Storage Forensics, Endpoint Evidence. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Chad Tilbury, SANS Senior Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Chad.
Hey, good afternoon, everybody. Well, for those of you joining from the US, hopefully this talk will be a nice reprieve from all of the emails that have been piling up after last week's holiday. If you didn't have a holiday last week, I'm sure you have one coming, so look forward to that. But anyway, thanks for tuning in today. I imagine, like a lot of you, in my practice, I'm seeing just a rapid increase in the amount of cloud storage components, artifacts, and questions that I have to answer. From everything from employee theft cases, external intrusion cases, and even some ransomware. And I would say without a doubt, many of you attending today are probably also experiencing this. That's probably why you're here. But when I started looking into this, I was really astonished at how little public information is available on cloud storage forensics. It's not like this is a brand new application that we're starting to see on systems. And for something so ubiquitous, it's an interesting niche that really requires a lot of research. So my hope is that I'm going to share what I've done today, and my hope it will inspire many of you to keep the research going and maybe dig into some other components of cloud storage. Just a bit as an administration, as Carol mentioned, there will be a recording of this. That's great. Also, the slides will be available pretty shortly after this webcast is over. So they should be at the same location as where you registered. Also, what I'll end up doing is I'll probably push questions to the end, and I'm pretty sure we'll have enough time to do some Q&A afterwards. So that works for everybody. All right, I won't bore you with my bio. I do want to give a shout out to SANS Institute for hosting and distributing this webcast. This is one of many webcasts that are available out there, and I think SANS does an awesome job of collecting a lot of important information and getting it out to the masses. So you probably know that you're here, but anyway, thanks to SANS. I'm a longtime instructor at SANS. I'm a co-author of our Windows Forensics class and the Incident Response class, 508. And in my spare time, as you can see on the slide, I get to do a little bit of skiing. I was just talking to Carol, actually. I literally have 20 inches of fresh powder outside my front door. So winter is definitely here, at least for those of us in the Northern Hemisphere. And I got a feeling it's here to stay. So if you're excited by that, nah, well, it doesn't matter, does it? Anyway, my contact information is here as well. I'll put it up at the end in case you want to chat or dig into something that I talk about later. All right, what we're all here for, cloud storage. So, the big question is, in a world where some of our most important data is really only present on third-party systems, how do we accomplish the same level of forensic investigations that we used to do? Without a doubt, cloud storage is here to stay. It's ubiquitous across both just personal consumer systems, business systems, and it causes some interesting security and forensic challenges that I think a lot of people haven't quite worked out in their process. So really the purpose of this whole presentation is really to answer the question, is there anything left on the endpoint that is of use to forensic investigators? Or do I have to get everything from the cloud? And I don't want to ruin the rest of the presentation, but those of you that have been doing forensics for a while, I think you know the answer to that question. Undoubtedly, yes, there's going to be a ton of data on the endpoint that we can also take advantage of. And so we're going to dig into that pretty deeply. There's just so many complexities between these different cloud apps. I've really focused on the four you see here: OneDrive, Google Drive, Google File Stream, Dropbox, Box, but there are hundreds of others. And not only that, it gets even more complicated. Even between OneDrive, you've got the OneDrive Personal or Consumer Edition, and you got the OneDrive Business. Same with Google Drive and G Suite. Same with Dropbox. And so we have, in many cases, significantly different applications, even between the same vendors. And then these different versions, have different sets of data, different logs, different databases in different locations. Many times the business versions have additional features like on-demand or selective synchronization components, different retention times, even across the same vendor, same product, just basically branded for different audiences. You have different retention times for things like deleted items or logs, or much more robust logging, say on the business side than you do on the consumer. So anyway, the the field is large, and I'm hoping to bring some sanity to the madness today. But there's a lot to dig into here. So as I mentioned, I'm going to really focus on OneDrive, Drive, Dropbox, Box. There are hundreds of others. My hope, and this is I'm talking to myself as much as to you, is that kind of understanding some of the nuances and the tricks of the dominant applications will make investigations of some of those unique snowflakes out there easier when we get to them. We can't predict that you're going to have that 1 in 1,000 weird cloud storage app that someone downloaded, but I bet it's going to look a lot like one of the major ones that we run into every day. And so that makes me feel a little bit better about not getting so overwhelmed with the sheer variety. All right, so what to collect here? So we've got a large amount of data that we should expect to find actually on the endpoint. So it won't surprise you, local files. And so a lot of this is all about kind of synchronizing local files to the cloud. So those are definitely going to be available. Also cloud files. So we're going to, on the endpoint itself, often be able to enumerate files that only exist in the cloud, that literally maybe have never been on that endpoint, but we'll still be able to get information about those. And I think that's a really important point, an important kind of tool in our toolkit of identifying cloud storage usage. The databases and logs, a wealth of these logs and databases exist locally. They're an absolute treasure trove about how that cloud storage app was used. And often there's a different set of databases in the cloud that we can take advantage of. So these can provide information on file metadata, historical evidence of files created, deleted, modified, even things like when files were shared by an individual user. So this is going to be a really important artifact that we need to make sure that we're acquiring when we're doing our investigations. So this is a forensic talk. No surprise that deleted items may be available. One of the really interesting things is it depends on the cloud app, but deleted items may be around forever. So that's going to be a big advantage. We'll see an example of that coming up. And then finally, it won't surprise you that we have so many local just operating system artifacts that can tell a story about cloud storage. We're gonna dig a little more into this very shortly here, but this is just traditional forensics on, let's say, a Windows system is gonna often point us in the direction we need to go. All right, let's go into a few of these in depth. So as I mentioned, local cloud storage files, we're looking at Box here. As you might imagine, if I'm in the folder of a cloud storage app, and the local files should be there. Now, I'm being careful here because actually Box is a great example, and we'll see later that doesn't necessarily mean they will be there. Technically, they should be on the local system, but the question is where. They could be cached. There's a lot of weird hackery going on with some of these apps, and we'll talk about why shortly. But in general, if it's a local file, we should expect to be able to get at least knowledge of it, if not the file, and if not that, often we can get things like MD5 hashes. So local files, that's a no-brainer. The new hotness, of course, in cloud storage apps are these kind of on-demand or cloud-only files. So to the user, it's not always really obvious whether the file's local or in the cloud, and that's the whole point. These apps are trying to kind of seamlessly integrate cloud storage with the local system. And this is really the future of cloud storage in general. And so to the user, hi, I just see the file there. Of course, we know the way it works. Technically, the file is not there. The file is only available in the cloud and gets brought to the system kind of on demand. And so we're going to need ways to kind of enumerate these files. We may see them cached. We may see evidence of them in database or other files related to the cloud app. And certainly, we'll talk about how we might be able to go to the cloud and recover these if we can't get them on the local system. All right, then some of the more interesting things. I was really surprised to see so many databases and local logs stored for many of the major cloud apps. Just an unbelievable wealth of information. So we're basically kind of looking here on this top here with a database coming out of Dropbox. This is the file cache.dbx file, if you're aware of that. And basically, we're seeing a listing of everything on the local system, so everything that's contained in the various synchronized local folders for that system. And then you notice at the bottom, we're also seeing a list of files that are only available kind of in the remote or the cloud component. So these could be files that literally have never been kind of on this local system, and we can still get a decent amount of metadata often for these, including things like timestamps, file sizes, depending on the app, sometimes hashes of the actual files, so we can actually definitively prove what a file actually is. Just becoming an amazing kind of resource for us to be able to, let's say, enumerate things that we may not have access to. Let's say we don't have credentials to the cloud instance that this user is using. There may still be a lot of evidence on the endpoint that points us to what's in there. And of course, that evidence could be interesting to our cases. So that's a great example of a database that comes out of Dropbox. Here's a great example of a log. This is the Box application stream log. And this is really cool. Several of the applications actually record the local kind of usage of the app. And so what we're actually seeing here is we're seeing Box recording literally every time a file is opened by a user. Almost always these databases and logs are based out of the user profile. So they're all going to be tied to kind of a user account. And what we're seeing here is basically this user used Acrobat Reader to open up this PDF from the Project Mayhem folder. And in this log, you'll also see things like this user deleted this file, this user created this file, this user renamed this file. So a very kind of detailed view of step-by-step usage. Not just the fact that the file is there, but now we can actually interpret kind of how the user was interacting with those files. Now, in addition to databases and logs, we're also going to often need to collect additional kind of helper files. And this database we see here is a great example. The file cache.dbx file in Dropbox is actually encrypted. Dropbox is kind of unique across the applications I looked at in that its standard metadata files are encrypted. So we're going to have to also collect the credentialing components off of Windows at the time of collection to make sure that we can decrypt those. And we'll talk about kind of some help we have to allow us to make sure we don't miss those. But one thing I hope you take away from this is a great example of data that is not available via the cloud API. Now, some of you probably have nice, shiny commercial forensics tools that allow you to collect data from a cloud instance. That's great, and we're going to see that. I think that's a really important part of the toolkit. But there is data on the endpoint that literally you can't get from the cloud. And so that's one of the key points I hope you take away today is that really to do a complete investigation, you kind of need to get both if possible. If you only have one, to be honest, I'd probably take the endpoint data, because as you'll see, we just have a very rich selection of things to work with here. All right, so these are the kind of the local databases and logs. Similarly, at the cloud level, depending on the application, you may likely have kind of administrative logs. So definitely for all the business products. So anything G Suite, OneDrive for Business, the Dropbox business components, all those have detailed kind of audit logs that we can deal with. Typically, you get to these through the admin panel. And so what we're looking at here is actually the OneDrive Unified Audit Log. So we can get to it via the web interface. That's what you see here. You can also get to it via PowerShell. You can actually get to it just via the API if you want to write your own tool, or that's how a lot of our commercial forensic tools are grabbing this data. They're just using the vendor APIs. And once we get it, no matter how you get it, you can see how we can quickly drill into activity. So the OneDrive log keeps about 90 days of retention across every user, and it records data on well over 100 different activities. And so what I've done here is I've drilled into a specific user called Paul Jones. And if you look under activities on the left-hand side, I've picked about 26 of the literally 100+ different activities I care about. So I can get a quick view of how this user has been interacting with this cloud storage instance. And so you see on here, we've got files deleted, files accessed, files uploaded. That'd be an idea of a new file created and pushed to the cloud. Files downloaded from the cloud. So if you're wondering if maybe you have some sort of team space, right? So you've got lots of your business documents all in one place, and you're wondering, well, what files has this user been interacting with? Well, it's very, very clear to see which ones they've been downloading, opening, and I think maybe even most importantly, you'll notice on here the used anonymous link or created anonymous link. What we're seeing there is someone is essentially sharing a file. In this case, sharing it in such a way that they didn't provide an email address to OneDrive, so they can just provide a link to someone. And then we can kind of drill into that and say, well, what was the file that they did it? When did they do it? You'll notice in here, we even have things like IP addresses of the endpoint. And sometimes we can get down to the individual person's computer that they are at. So were they at home or were they in the workplace kind of when they were doing this? So just a very detailed view of kind of, again, that usage activity of these cloud storage. OneDrive, 90 days by default. G Suite, if you're lucky enough to be there, 6 months by default. So a ton of data kind of sitting in some of these cloud apps. Okay, so this is a great example of something you do have to go to the cloud. So in this case, you'd need admin. Your admins would have to grab this. And I would really recommend, if you are in kind of a standard enterprise environment, you have some of these products, I'd recommend getting some of the logs, get some sample logs from your admins now and start taking a look at them. Now, they're not perfect. They can be really frustrating sometimes to understand what they're telling us, and sometimes they just don't log things you think they should. They're as good as you're going to get, and I have seen them get better over time, and I expect that the logs will continue to improve. But it's something that is worth getting used to before you need it. And those are the things that consultants, well, you need to do it across all the products because you really don't know what you're going to run into when you get into those different environments. All right, so those are the logs kind of sitting up on the cloud. So we talked about deleted items. One of the interesting things about these cloud storage apps is we may have deleted items on the local system as well as deleted items in the cloud, and they are totally independent of each other. Super simple artifact. We've all been digging into the recycle bin since the recycle bin existed, but kind of looking in here, I'm always paying attention to those full paths. Not only here, but across any artifact, to be honest. But when I start seeing paths that have OneDrive in them, well, that's a pretty good clue that we've got some files that were once in a cloud storage folder and that have been since deleted. One of the nice things here is, in this case, it looks like the files still exist in the recycle bin, so we could actually recover those. And those may be files that literally no longer exist in the cloud. So it could be more data on the endpoint that literally have been long kind of aged out of whatever's in the cloud. So don't forget those kind of local deleted components, just standard forensics here. And then, big bonus, we get another set of deleted items sitting in just about every cloud app. So every cloud app does this kind of a little bit differently. So I think the retention for OneDrive is somewhere between 30 and 90 days, depending if you're in the consumer or the business piece. But what we're looking at here is actually Google Drive. And look at the last modified column here. Look at the time range. That should be a big clue about what the retention policy is for Google Drive. And as far as I can tell, Google Drive keeps items in the trash folder indefinitely. I assume at some point you'd fill up your storage and the user would have to clear it out. But most users never even pay attention to these folders. So not only does Google Drive keep them forever, the user probably keeps them forever too, because the users aren't going to be interacting very often with these folders. So anyway, could be a wonderful source to kind of go back very far back in time to get some interesting data for us. All right, and then last but not least, standard operating system artifacts just coming off of Windows itself. Now, this is a pretty interesting list. As I started making it, I started thinking, my God, like literally this is about every artifact we deal with has the potential to maybe give us information about cloud storage. And I don't think this is necessarily comprehensive. You could probably come up with 5 more that would be likely relevant. I think what many of these all have in common are they kind of help identify files and folders that exist by full path. Right? If we can use that information, what we're looking for essentially is interesting cloud paths. You know, OneDrive, Google Drive, My Drive, Dropbox, Box. You can come up with a pretty quick little list to search through. And we're looking for kind of references to those cloud paths in this wide variety of artifacts that we use every day. You know, as an example, here's a link file. So if you're not familiar with link or LNK files, these basically tell us files and folders that a user has opened. And so a wonderful kind of place to quickly identify the most commonly and most recent open files from a user. So you notice we're on here and we see a directory called OneDrive under PC user, and it looks like there, at least at one point, was a file there called Stark Level 7 CryoDNA Storage Inventory. Awesome. If that's interesting to my case, well, that's my first clue that OneDrive's in play here. And so that might lead me to go pull those databases and logs, go to the folder to collect some more information there. This is also really important because, as we'll see here shortly, some of these paths can look really weird. They can be kind of these virtual paths, or they could be other drive letters. And this information is going to kind of really help me maybe pick up things that I might have missed. You know, especially in folders. As an example, any user can rename their cloud storage drive. They can put it on a different volume. There's a lot of kind of techniques that you know, maybe a more savvy attacker might use to try to hide these. Well, these artifacts are what would likely lead us to those anyway. You know, a great example. So this is coming out of the registry, but a lot of times in the registry, I'll simply literally search the entire registry for that OneDrive, Google Drive, My Drive, Dropbox, looking for any registry keys to kind of hit across those really well-known names. So for what we're seeing here is this is actually Google File Stream. So this is the G Suite storage apps. This is what replaces Google Drive if you're in the G Suite world. And My Drive is what that drive is called. And actually that's a really weird application in that it creates a completely new virtual file system. It's actually, believe it or not, a FAT32 file system, which is just bizarre, and it mounts up as a drive letter. So now I not only know that Google File Stream's on this box, I actually know that what drive letter it's sitting on, so I can tie other artifacts to that. And then one more example. This one's awesome. This actually came about. Rob Lee was asking me about it. He's like, hey, I keep getting these errors when I try to move some files over to a thumb drive. It's based on alternate data streams. I was like, what do you mean? He's like, yeah, it seems to be when I'm moving my Dropbox files over, there must be an alternate data stream there or something. And so sure enough, we started looking into it, and very cool. Dropbox actually tags files that have been synchronized from the cloud with an alternate data stream with the name Dropbox on it. What's nice about this is these get moved even to other volumes or other locations. As long as it's an NTFS file system, these alternate data streams will just stick with this file. So this file might be moved 3 different places, and we'll still be able to tell that it was originally kind of pulled down via Dropbox. So great example, just a regular classic forensic artifact like these. You might be familiar with like things like zone.identifier alternate data streams we've been using to prove things have been kind of downloaded from a browser, etc. Well, we can use those now to also identify Dropbox. And I guarantee there's other cloud storage applications also using these similar type of alternate data streams. Bottom line, if I look through all these artifacts and I saw no cloud storage, I would actually be shocked and pretty suspicious. Cloud storage is so pervasive now. Bottom line is I just expect to see it in every one of my investigations. So we should see multiple artifacts kind of all pointing me to the same place. Hey, OneDrive's in play on this system. All right, so that should hopefully give us a pretty good idea of why we care, what we can get off these systems. Now the devil's in the details, of course, and collecting all this data can be challenging. It's definitely more challenging than I expected when I started digging deeper into this. But we'll start with something that most of you are probably pretty familiar with. Is we've got a fair amount of tools out there that can collect things directly from the cloud storage vendors themselves. So this is definitely something that you should determine if you have these tools or if you need these tools in your kit, because this certainly won't be all the data we need to do our investigations, but it's a really nice benefit. Now, one thing you need to keep in mind is if you're collecting things from the cloud, all the solutions really require proper credentials, or almost nearly all of them. So this is the idea of either the user gives you the credentials, or maybe in some cases like the business components, you might have an admin account that you can get in and get this data. Either way, if you have those credentials, there's a bunch of different options here. On the free side, a lot of the different vendors have free abilities to pull things out, whether that's Office 365, I have on here Google Takeout or the G Suite kind of export tool. If you've never used Google Takeout and you've got a Google account, you should go do it. It's amazing. It's so easy. Basically, you just quickly select kind of what you want. About 10 minutes later, you'll have a giant zip archive, and you can determine what you want to do with it. Same thing with the G Suite. They actually call it kind of customer takeout, and it's done via the admin panel. But you can basically dump everything from every user in your environment, should that be interesting to you. In addition to kind of all the logs, all the files in their G Suite kind of file stream, cloud app, basically everything you could imagine that that might be interesting to your case. Now, in addition to those kind of vendor-specific tools, there's some great commercial tools out there. I've got FResponse and Magnet Axiom on here. There are many more. You see kind of Magnet at the bottom. That's where you can see the signed in. That's the clue that we had to provide credentials there. And then you just see kind of some of the support that you see with FResponse. Bottom line is make sure to test your tools. So in general, cloud collections can be really time sensitive. This is probably one of the first things you want to do when doing a cloud case, because this is one of the things you don't have control of. You might be able to isolate the actual endpoint to make sure there's no changes to it, but isolating that cloud instance can be much, much more difficult. You can't, for instance, stop maybe your subject from going to a different system and starting to remove data from that cloud piece. So this is one of the first things that I typically want to do, and I think it's going to be important. And time's of the essence. So you want something that will work the first time. So get some tools, test them in your environment, make sure that they operate as expected. Also, just note that many of these tools might not get everything. There's a great example, for instance, several of the different cloud app providers provide versioning. So literally, they'll allow you to get via the API every single version of, like, let's say a Google Doc or something along those lines. What I've noticed is a lot of these different commercial products don't get that. And so if that's really important to you, you're gonna have to find a way to get that. There was a great presentation on this by Ashley Holtz at the a past SANS DFIR Summit. And she did a pretty good deep dive on Google Drive. So if you search for Google Drive and Ashley Holtz, you can see kind of how she had to go and actually write code against the API to kind of pull down the different versioning. But just note, these will get you most of what you need, but there might be other interesting things available. And so just keep yourself up to date. All right, so what about kind of at that endpoint component? And this is the good old days for sure. So the first generation of cloud apps, these were really largely designed to just be super simple, synchronize local folders to a cloud instance. So I pretty much call these cloud backup apps. Now, most of the major cloud storage apps we're dealing with today started this way: Dropbox, Box, even OneDrive. There are many, many other kind of just backup applications that you might run into as you're doing your investigations. And in general, these are some of the easier ones to take advantage of. They're really designed kind of to synchronize entire folders, typically up to the cloud. And so you can collect the local data, and typically that's going to match what was in the cloud. Now, keep in mind that that might not be everything that's in the cloud. It might be everything on the cloud from the system you're currently working with, but there might be multiple devices all synchronizing to the same service. So this is a place where you still need to have like all of the user's devices to truly kind of get a full mirror of what was in the cloud, because each device might be backing up different folders. But in general, these tend to be a lot easier to collect data from and really kind of have most of the data we care about without needing to go to the cloud. Of course, those are the good old days. The new hotness now is these kind of files on demand. And so this is basically, again, what I mentioned earlier, which is the ability to essentially show the user all files that are present in their cloud instance and allow them to interact with them, even if they're not local yet. So files clicked, it just gets immediately downloaded and then just opens normally for the user, in many cases almost seamlessly. When a file is kind of modified and then saved, it just gets kind of uploaded back to the cloud provider in the background. So Box Drive was actually one of the first to implement this feature. It was very quickly followed by OneDrive. I think it was the creator's fall update or something crazy like that with Windows 10 that rolled in this new change. And then Dropbox has Smart Sync, and basically all the major commercial tools now are implementing this feature. Now, what we're going to find here very shortly is in order to make this work and be seamless for the user, there's going to be some weird stuff often going on in the background, and that's going to complicate some of our collections. We're going to really have to take that into account. But one of the great big takeaways when you start seeing columns like you see here on the right, you see the names and then you see the status. You see some of those files have check marks next to them. Those are the ones that I would expect to see local to the box. The ones with the little blue cloud, those are the ones that are likely only available in the cloud. Except we've already talked about how some of those local databases might help me enumerate what was in those folders as an example. So anyway, simple takeaway here is the local system on some of these more advanced apps likely will not have a complete copy of all the files available in the cloud provider. There are probably a lot of files that have never been downloaded on that endpoint. And so you wouldn't expect to be able to necessarily recover them from the endpoint, but we'll have those databases and log files that can, and the Windows file system artifacts maybe that can help us start to fill in those gaps. All right, so these on-demand apps are definitely providing some challenges to acquisition. And this was actually scary for me when I started digging into this. It made me really think about all of the data that I personally been missing, and maybe others have been missing with acquiring some of these, or assuming that data would be there that actually isn't. So to make all this cloud magic happen transparent to the user, there's all these kind of tricks going on. So multiple cloud apps take advantage of kind of this feature of NTFS called reparse points. These are essentially like file system redirects. You can actually see it. If you look at that red arrow on the screen and you see the little box icon, do you notice how it has a little kind of arrow on the icon? Well, that's the clue that actually that's not a real folder. That's actually a reparse point. And so essentially that folder is not a real folder in Windows. It's just sending you someplace else to where those files are. To the user, who cares? It looks like anything else. They go in there and their files are there. However, if you're just looking at the hard drive, as we'll see here in a moment, you're going to be sorely disappointed in what's in that folder. So basically, we're going to need to adjust our collection process to make sure that we're not missing kind of some of these new weird redirects or symbolic linking that's been going on with some of these applications. So Box in general, we're gonna see an example of. Box actually uses something called it's a Windows feature called a callback file system. Essentially, it allows it to create a virtual volume, like a file system, that's accessed via this reparse point. The files are actually cached kind of on the box, and then they magically appear in this folder via this kind of reparse point and this virtual kind of file system. So definitely a interesting implementation, but it's something that is really easy to miss if you're not paying attention to when you're doing your initial acquisition of evidence. So how are we going to deal with this? Well, I'll have an example here in a moment, but in general, the best case scenario is actually capturing the data on a live running box with the user logged in. If you have that set of criteria in your favor, you're all good. So if you can get to a live running box and the user is still logged in, well, these virtual file systems will be available. You can collect them, and you're going to get the best of all worlds. Should you not be that lucky, well, there'll still be some databases and log files that can help us fill in the gaps. You're likely not going to get the actual files. You might, depending on the application, there might be some cached components of them you can gather, but it can be quite difficult if you didn't collect the data on a live running box. Other than that, you can also collect, of course, things via those cloud APIs. So as we mentioned, that's not everything, but that's not a bad secondary option, or maybe it's your primary, and then whatever you get off the endpoint is adding to that. But in general, this is pretty different. The old school model, yanking the hard drive and doing an image of it, in the cloud storage world, is going to make sure that you miss a lot of important data. And I know what you're thinking. You're like, well, I'm not going to deal with any of this. I'll just collect via the cloud API. That's good enough. Just note that sometimes what's in the cloud is not useful at all. So I'm thinking of like third-party technologies like Boxcrypt. And so in my last job, we actually used Box, and we used Boxcryptor, which basically means everything in Box was encrypted. And to be honest, that's kind of a best practice for a lot of organizations. So you might be able to collect things with the cloud API, but it may come back completely encrypted and useless to you. So again, that's why sometimes this endpoint is going to be important for our collections. All right, let's drill a little more into that box. So here's a great example. So I'm on a system. Let's say I take an image of a box. I have a full disk image. I go load it to my forensic tool of choice, and I go to that box folder. Now, unfortunately, there's nothing in there. Now, that might lead me to really make some wrong conclusions, like, well, maybe it was never used, maybe it was installed and the user didn't use it, maybe the user cleaned everything out of it, but actually none of those are necessarily true. Because if you kind of look at the contents of that folder, you'll notice something really strange. What I would expect to see in the contents of a folder in NTFS is maybe some attribute information, maybe some $sign I30 and directory indexes in here, something that tells me this is a folder. Instead, literally all we get is a volume GUID reference. This is actually the volume GUID that reparse point is using to get to that virtual file system. So the good news is if you get this, well, you at least know that Box was installed and in use. There was a virtual file system associated with it. The bad news is, well, you're not going to get any of the locally synced files because you didn't capture those during the acquisition. So this is just a great example of like missing data. Right? Now, let's say that we're on the same box, but we have to get there when the system's live. And so let's say we use FTK Imager in this case, not to do a full disk image, because that's just going to get the reparse point. You actually have to point at just a logical collection of that folder. And basically that will spawn windows to traverse that reparse point and then get you to the actual virtual file system to collect the data. And so in FTK Imager, the way we do this is the contents of a folder. And so if we were to select contents of a folder pointed at box, now you'll see that we would actually be able to recover all those files located in that folder. Now, when I first kind of saw this and started playing with this, it's like, man, I don't want to do that for every investigation. So I've got to like identify literally every cloud app, and then, you know, folder by folder, do a logical collection of them to make sure I'm not missing anything. And that was not something that I was particularly kind of excited about putting into my process. So the good news is there's an alternative. So FTK is definitely an option. It's not a bad one to have in your back pocket if you're using FTK Imager anyway in your process. But that's a really cumbersome way to do it. A much more repeatable and fail-safe option is to really use a scripted collection tool. And so when I think of scripted triage collection tool today, I think about the KAPE project. So if you're not familiar with KAPE, it's definitely one of the more exciting recent forensic projects released to the community. Free tool, written by Eric Zimmerman. It just greatly simplifies acquisitions and processing of forensic artifacts. And just make sure that you don't make mistakes. It's something that you can just set up ahead of time, and you just know that it's going to get what you expect. It can be run on a live system, a mounted image. So if you've already got a disk image and you just want to collect things off of it, you can run it across a drive attached to a write blocker if you need to do something just very quickly. You can even run it across the network if you're doing kind of network-based collections. So a super powerful tool. I'm guessing, you know, the number of people that we have on this webcast, that many of you have probably played with it. But if you haven't, the way it works is via these target files. And so you're actually looking at a target file right now. And so essentially the target file defines location and acquisition options for a particular artifact or a particular collection of artifacts. And so we're essentially looking at some target entries for box and Dropbox as an example. And super simple, obviously text-based, and a really easy way to enumerate what I expect the tool to collect. And so when I was doing kind of my research, it was super easy just to kind of create some interesting targets. So you'll see now in the KAPE repository, there's one for Box, there's one for Dropbox, one for Google Drive, one for OneDrive, both the consumer and the business side of OneDrive, and they're all included now in the default installation of KAPE. So there's tons of random logs and database locations. Like if you look at that bottom entry with Dropbox metadata, that's the location of that file cache.dbx file. They also collect things like the local files necessary to, say, decrypt the Dropbox components. It just makes it really super easy to enumerate everything I need to do my job after collection. Now, one thing you'll notice in the list on the right, you've got Box Drive, and then you've got cloud storage. That cloud storage is actually kind of a metadata target. That target actually points to the other 4 that are highlighted here. And if we get lucky and there's more research done, and someone, let's say, adds a target for iCloud in the near future, we need one. So if you've been doing any iCloud stuff and you have the information necessary to write one, you could write a quick target. You could reference that within the cloud storage target. And now when you run that single target, it will run everything related to the different cloud storage apps. Right? So that's kind of like a meta one. You can use one, a few, or you could just use cloud storage to do them all. Right? So really simple way to kind of batch kind of things together. Now, hopefully by looking at this, you see it's super simple. Also, I want to talk about kind of the items in red on this slide. So these are kind of some new components that had to be added to KAPE to help us get around some of that weird hackery that these apps are doing. So you notice follow reparse point, follow symbolic links. You don't need it for every app, but certainly for the apps that are creating these weird virtual file systems, that's when you end up turning on kind of the follow reparse point and follow symbolic links. And that allows KAPE to do essentially what we saw just a moment ago with FTK Imager, to kind of do a logical collection, jump into that folder, follow the redirect, and then collect those files from there. Now, super helpful. I mean, I don't know of a better way to collect, but one important note here is that you got to know your tools. And so obviously when you're creating your process and creating your standard build for which targets you're going to use, keep in mind that these targets are built really only around default locations and names for these cloud storage apps. Unfortunately, users, when they install the app, can choose different names in different locations. And so there's no means within KAPE to iteratively look for a wildcarded folder. And as such, what you'd have to do in this situation where someone actually pushed their cloud storage in a non-standard location, you'd have to update the target file to collect from that location. And we'll see kind of a process flow chart at the end here. And I've added that step into the flow chart just to make sure you don't miss it. You know, in general, I mean, I would like to, I would probably bet 90% of users leave everything in the default locations, but I'm sure you've seen kind of the outliers out there, and so we have to make sure we don't miss that. And this is where we have to bring the fun police in. I have to give you a word of caution. With great tools comes great power, but also great responsibility, or whatever, however that saying goes. There's some things here that you have to be aware of. If you turn on that kind of symbolic link and reparse point components of KAPE, it will follow those redirects. If you happen to be on a live system still connected to the internet, it will very likely start to request files from the cloud, download them from the cloud, and collect them for you. What it looks like from the standpoint of the operating system is it looks like the user is opening a bunch of files through those reparse points. And so the OS will nicely, or the cloud app, will nicely just go grab the files for you and collect them. Maybe you want that. It's an awesome way to do cloud-based collection without having to go log into the cloud to do it. But what I want you to realize is you may not have the authority to do that. And so this is something, especially if you're law enforcement, or to be honest, even in the business world, users have expectations of privacy. This is something you want to get a legal review on and make sure that you have the authority to actually collect in that way. It could be a really super useful feature, or it could get you in a lot of trouble. And so you'll notice actually in the target files, there's actually a comment in there to remind you, hey, be careful, you may not want all these files. Unfortunately, there's no way to only specify local files. It's basically the tool is going to iterate through that reparse point and just collect everything it can. Now, a really easy workaround here. Just make sure that the system that you're acquiring from is not connected to the internet. If you can do that, well, it's not going to be able to go out to the cloud provider and grab anything additional. So in general, we like to isolate our systems when doing collections. We prefer to make sure no one comes back in and starts deleting stuff while I'm collecting. So that may already be part of your process. If for some reason you can't do that and you're worried about your scope of authority, worst case, you could go on just on the live box and manually collect the local files. You can actually see which ones are local versus the cloud, take screenshots. Yeah, I don't know what your process will end up being, but it's something you need to think through here, right? Just don't blindly run this tool and then be amazed that you have gigabytes of data that was all downloaded from the cloud and be like, huh, I wonder where that came from. The good news is you go to the databases and probably figure out what was originally in the cloud and not, but the bad news is you might have collected a lot of data that you weren't allowed to. So just be careful. All right, don't want to be a downer here, but to be honest, that FTK Imager would have had the same problem. Any way that you collect those reparse points is going to have the exact same problem of just collecting everything the cloud app will let it, as long as the system is able to reach out to the internet and grab those files. All right, more on KAPE. Bottom line is we just talked about using the target files for cloud. Remember, we have all these other artifacts that can also help us in our cloud investigations, from registry hives to the recycle bin, link files, prefetch. The browser artifacts can be very useful. So there's well over 100 different targets in the GitHub repo for KAPE. There's also almost 100 modules. If you're not familiar with modules in KAPE, these allow you to run other tools and parse data. So super crowdsourced collection, and the fastest way I know for us all to share information. I really love how easy this makes it to share. I had, when I was doing all this research, I had all these different locations where file and metadata were for Dropbox and for Box versus OneDrive. And ordinarily for me to share that, I would have had to write up multiple blog posts. And then each one of you would have to read those blog posts and synthesize the information, update your collection tools to gather it. Instead of going through all that, literally I just wrote a couple target files. And now when you update KAPE, well, if you care to collect that, you already have the target files to collect where they are. So just such an easy way for us to all share information. Yeah. While I'm doing the KAPE Love Fest, it would be remiss of me not to mention that you can also collect data from volume shadow copies with KAPE. This is important because one of my favorite use cases for volume shadow copies is cloud storage. A lot of times if I see a cloud storage folder, I can see the current files in there, but I would love to know the files that used to be in there, maybe last week, the week before that, the week before that. And so a lot of times I'll iterate through the shadow copies, kind of looking to see, was there something interesting there a week ago that wasn't here on the current system. So KAPE can automatically do that. You literally just give it the VSC option. It will iterate through all the volume shadow copies, and it even does deduplication. So it'll deduplicate anything that's not unique across those different volume shadow copies. So it makes it super easy. And it's of course not just for cloud storage, it's for every artifact. So just another big win when you're using this tool. All right, man, I've been talking a lot. Let me do a quick live demo for you. We'll see if this will actually work. I just wanted to get as many of you off the fence as possible. And maybe the best way is to kind of show you how it works. So let me see if this is actually showing up on your screen. Looks like, yeah. So you're looking at a virtual machine that I've got. And so if I go into the KAPE folder, this is what you would see if you kind of downloaded KAPE. You'll notice kape.exe, that's the command line version of the tool. You'll notice there's a nice GUI version of the tool that we'll get a look at here in a moment, as well as a way to just quickly update all your targets. That's this little PowerShell script. And then your various targets and modules are located in a folder. And so if we were to go into targets apps folder, you would see, for instance, we've got Google Drive in there, or we've got Dropbox, Cisco Jabber, many of the targets that you might care about. Okay, so I'm going to bring up GKAPE. All this is basically a front end that builds your command line for you. So if once you have your command line, you can easily just use the command line version. Okay, so bringing up GKAPE, I'll say use target options. I'm going to point it at the C drive of this virtual machine. So I'm basically going to do a live collection. I need to give it a target. So I'm going to browse to my location I care about. Just put it on my G drive. I'm going to remove the flush. What flush does is essentially clean out that folder, make sure it's clean. I might have stuff in there I want, so I'll go ahead and just leave it. And then you'll notice under there, we've got a vast variety of the different targets that you just saw in that folder in the file system. And so what I'm going to do is kind of scroll through here. I'd select the targets of interest. So what I'm looking for are under apps, and I want the cloud storage. So this is that meta target that will run all the different cloud storage apps for me. You'll notice it defaults to deduplicate, and I can select volume shadow copies. I can tell it to put either in no container, in this case, one of my favorites, the VHD format. If I do that, I kind of have to give it a name. So I'll name it, how about just Cloud Collection, and remove the zip. And you'll notice here at the bottom, it's got our nice kind of KAPE components here. So I've selected what I want. I've got my command line, then I just hit execute. And this is probably not going to look great to all of you. It's basically going to scroll through thousands and thousands of lines as it's collecting data. But it looks like I saw scroll through here, it's collecting about 2,000 different files. And it's going to iterate through those different locations, then iterate through the volume shadow copies. It's going to hash everything. It's going to then deduplicate based on hash. It's going to log everything. So it's going to have a log that will have, say, all the timestamps for every file, including the hash information and file size information. It's going to have information on what was deduplicated in case I care. So there's a ton of great logging that comes along with this tool that we can also take advantage of. But in general, you'll see, I think it usually takes, at least on this system, a little under a minute. And it's going to kind of rip through. Looks like it finished in about 49 seconds. And now it's making a VHD file to dump everything into. And I love how Eric does stuff. He's so manic about efficiency. So it looks like in exactly 59.5643 seconds, we have our data, right? Okay, so let's take a look at this then. I'm going to go to that output folder. And in there, actually, I see a couple. This looks like my most recent one, and it's a VHD file. Right? So the beauty of these VHD files is I can just double click it and it will pop up as a drive letter. And so now I can see the contents of what was collected. And so you notice I can go into the C drive here, under program, well, let's go into users, under the user account that was collected. I can go into the app data folder, local, looks like there was some data related to Google. That's the drive file systems, that's the Google file stream. It looks like it collected things like the logs and databases for Google file stream here. I can go back and look at the actual contents of the folders themselves. The files will be in here if they were available. And of course, we have those files now nicely in a little VHD file that I can move around and analyze at my convenience. So within a minute, nicely was able to kind of collect all those items. Just so you know, there are a few different kind of logs that's important for you to understand. So you notice inside of this VHD file, there's a copy log and a skip log. So if we open up the copy log, that'll give you a quick idea of kind of the metadata. This is probably really large on your screens, but give you a quick idea of kind of the metadata that we can work with here. And so it shows you the full path of where everything came from, the actual timestamps of those files created, modified, accessed, the actual SHA-1 hash, file size information. If I open up that skip log, this one's important because we did do deduplication. So if you're doing volume shadow copies, you probably want to deduplicate because you're going to have a lot of the same data across all your volume shadow copies. But that can actually be misleading to you because you might go into a folder and be like, well, I don't see the files that I expect to there. And I run into this a lot where when I'm doing testing, I'm like, God, why aren't the files there? Why isn't it collecting from Box or OneDrive? And the answer is because it did try to collect, but actually you'll notice that all of these were skipped because they were essentially deduplicated, meaning they were already collected from somewhere else. And so if I want to identify where else those files would be, I need to go to the skip log, and you'll notice I get the full path of items also that would have been collected. Now, if you want to get everything, just don't use dedupe. You know, if you're not worried about file size or you're not bringing this over the network or something, you don't have to dedupe, and then you wouldn't need to worry about kind of checking this log. All right, so doesn't get much simpler than that. So hopefully that at least gets you started and entice you to kind of go out and give it a shot. I don't know. This is not all about KAPE today, but it is something I want you all to be aware of because I think it really is the number one tool I'd recommend when doing endpoint collection of cloud storage. It's the only thing really that can get a lot of these other than something like FTK Imager. All right, let's wrap this up. So here's the process. So bottom line is if you have cloud credentials, well, I recommend getting the data from the API as soon as possible. We talked about this already. You don't know when that data is going to change or when that subject of your investigation might go online and start to remove data. So I like to get those as soon as possible. Then moving on, if you've got a logged on system that's live and the user's logged in, we'll score, right? You're going to get some good data, but you need to have a game plan because there's so many things that can be lost once you lose this live access. I think this is a big reason why so many recent law enforcement cases have gone through really extraordinary measures to catch perpetrators at the keyboard so they can get them when the system's currently logged in. This is, by the way, not just important for cloud storage, it's important for full disk encryption and file-based encryption and all these other challenges that we have in the modern world. So bottom line is that's a good start, but it's not gonna, we're still gonna have to do some work to get what we want, right? So if I'm on a live system, I'm gonna perform that default triage collection like I just demoed. Then I'm gonna go take a look. You'll notice the work's not over here yet. I'm gonna go audit that data that I just collected and or look at the live system to make sure I'm not missing things I expect to see. Like maybe I expect to see OneDrive data, but I don't see it. Could be because the user had moved the folder to some place that wasn't in one of my default known locations. So in that case, then I go to the final standard locations decision point, update my target file to point to those locations that I now believe the user is using, and do a secondary triage of those final components. The only reason we didn't do this first is I like to try to capture things as clean as possible before I start actually interacting with the machine. And so that would be kind of doing that default triage and then modifying as necessary. And then finally, if you don't have a turned on system or you don't have any credentials to access it, well, you're pretty much back to the old school dead box acquisition. You're gonna lose a ton of data, but at least you now know everything that you could have gotten, and maybe you can supplement that with what you grab off the cloud. And to be honest, you're still going to get a lot of those databases and log files, even not on a live box. So you're still going to be able to do a lot of cloud-based forensics. You're just not going to get everything kind of in that scenario. All right, I've talked for far too long. If this is your first introduction to SANS forensics, welcome. We have a ton of great resources to get you started. If you look at the bottom of the slide, everything from the Twitter account to additional videos on YouTube, a great mailing list. The material really germane to this presentation is covered in really two of our classes right now. So there's a brand new Forensics 498. So that covers KAPE and triage collection extensively. That's basically what the whole class is designed around. So that's a really kind of exciting class that we've just recently added to the curriculum. The Forensics 500 class really expands on all the cloud material, those databases and those logs, just taking advantage of that ridiculous amount of local metadata that we can take advantage of to kind of identify what was in cloud storage. All right, obviously my contact information is here, and well, if anybody can stick around, I'll stick around for any questions. But really appreciate your attention. I hope this was valuable for you all.
All right, Chad, do you see the questions in the questions window?
I do.
Okay. I didn't know if you wanted me to read them out or if you were going to.
All right, so I see a question. If you delete something off of Google Drive, does Google save a copy somewhere else, like a recycle bin restore option? So yes, Google Drive and many of the other cloud apps, when you delete something, there's typically a cloud-based recycle bin. So I think it's called literally trash in Google Drive. That has a retention point of forever, as far as I know, as well as wherever you deleted it from. If it was actually a local copy of it, you'll see it in the local recycle bin as well. So you can get it in either place, maybe both. Google Takeout, it says, I assume Google Takeout only works on Google products. That's true. So Google Takeout is really designed for the Google suite of products, everything from Gmail to Google Drive. G Suite has its own for all the various things there. But many of the other products have their own. As an example, Facebook has a takeout. Also, Office 365 has built-in capability to extract data. So look at your vendor that you're using. There could be already a tool they have that's free that comes with the product. Let's see, do you see any cloud vendors looking into organization enterprise key escrow for access to those APIs in specific use cases? Giving you, I assume, better access to kind of user-related data when you need it. I don't know of any of the cloud vendors that have any sort of key escrow going, but in my experience, we haven't needed it because you typically have a super admin account for those. And one of your admins that set it up is going to have that account. And assuming you can get to that account, you pretty much have access to every piece of information typically in those cloud instances. So typically the way you do it is you go through that super admin account to get the logging, to extract data from individual cloud storage boxes, etc. All right. I'm guessing that we're out of time, but again, thanks for everything. Hopefully this encourages you to go dig a little more into this stuff. And please, when you find some new things, post about it. Make a new KAPE target. Do a blog post. We need a lot more research in this area, and so I'm glad to have you guys out there also continuing the fight.
All right, thank you so much, Chad, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.